We will go briefly into how OVHcloud started KoP, and then we will talk about the protocol handler. We will speak about the difference between Kafka and Pulsar, and then how we implemented KoP. Then a bit of roadmap. AOP is another project that CJ will talk about, and then we will answer questions. So before talking about the why, the how, we can ask why we need KoP. So as you can imagine, there was like a huge increase of adoption for Apache Pulsar, thanks to a lot of really cool features such as the multi-tenancy, geo-replication, tiered storage, and so on. So, and I think I will be speaking for both of our companies, but we received a lot of inbound requests about the possibility to have Kafka protocol on top of Apache Pulsar, and that is really interesting to ease adoption of Apache Pulsar and also ease migration. And there was some existing efforts before starting the KoP, Kafka-on-Pulsar. The first one was a Kafka Java wrapper, which was exposing almost the same object as Kafka, but using Pulsar. This method was working only on Java, of course. And there was this Pulsar IO connector, which was pretty handy to replicate a Kafka topic to a Pulsar topic. But that was not enough. So we at OVHcloud, we started to think how we could implement such a thing as support of Kafka protocol on Pulsar. So there was like two main ways. The first one was the proxy gateway idea. So something that would be in front of Apache Pulsar cluster. And the second one was to implement Kafka protocol directly on the Pulsar broker. So I will just go briefly around the work, the proof of concept that we did in within OVHcloud. So we first implemented KoP, Kafka-on-Pulsar, as a proxy written in Rust. So Rust is a programming language that is enabling nice things such as no garbage collecting and performances close to C and C++. So we did study this proxy in Rust because we wanted to avoid garbage collecting on proxy layers. And the second reason is that Rust have awesome libraries to work at TCP level. So we imagined something that would convert TCP frames from the Kafka protocol to TCP frames from Pulsar. So we have something like this. We have our Kafka clients on the left. We have our Apache Pulsar cluster on the right. And we need this proxy, this TCP proxy on the middle that will just magically translate things up. So we developed this thing as a state machine. So we have a state machine for the Kafka connection, the TCP connection from Kafka clients. We have another state machine from handling a connection to Pulsar brokers, and then each TCP frames from each protocol were moving the state machine around. So it was like an event-driven finite state machines on both sides, and we added a third one to provide synchronization between those two. So it was looking like this. We have this state machine on the left, which was handling the Kafka connection, another one for handling the Pulsar connection, and the third one which was providing synchronization between those two. And this proof of concept was really nice. Working at TCP level enabled massive performances. We were network bounding on this proxy, so that was really nice. It was a nice proof of concept to discover both protocols, because we ended up rewriting everything from parsers to how to handle connection. If you don't know Rust, Rust is blazing fast. So if you may want to try another language, Rust is maybe the one that you need. One thing that we learned is that Proxify production message is really easy. And one thing that was really interesting is that we could bump old version of Kafka frames for all Kafka clients. So we could just add support for very old Kafka clients like 1.0 and just translate them into newer frames. So that was like the good part. The bad part is that we just rewrite everything in Rust. And there was something that was really hard to proxify. So I will get to it, but group coordination and offset management are really difficult to proxify. And one thing that was bothering us is that it was really difficult to open source it, because it was written in a completely new language and not in Java. So I will briefly go through the group coordinator offset problem. So in case you don't know, in Kafka, there is this thing which is called the group coordinator. It's an elected actor, and it's responsible for a lot of things, such as assigning partitions to consumer of a consumer group, and it's managing offsets. So that's the group coordinator problem. And we have this offset issue because the partition assignment is managed by the broker on a per partition basis. And offset management is done by storing the acknowledgement in cursors in Apache Pulsar. So the main problem here is that we don't have access to enough information on the proxy side. We need to have, internal fields from within the broker. Yeah, so the too long determined part is that simulate consuming at proxy level is really hard. You are missing some low level information. So we were like struggling with this proxy, and then we saw a tweet from StreamNative guys that were saying, okay, we started a demo about something we call KoP, and it was Kafka protocol support natively inside the Kafka broker. And we were like, okay, we definitely need to contact StreamNative people. And that's how we started our collaboration between StreamNative and OVHcloud.
Thanks, Pierre, and that's kind of the starting point of our collaboration. And so Pierre mentioned that we started work of implementing the native Kafka protocol in the Pulsar broker. And one of the reasons for us to do that is one question we keep asking ourselves is, what exactly is Pulsar? And so we kind of step back and take a look at how that whole overall architecture of Pulsar itself, and to see how Pulsar implement its own protocol. And so this is a simple diagram to an overview about the whole Pulsar architecture. So basically, you have zookeeper for metadata store. You have bookies for the data storage. And Pulsar provide a kind of a distributed log library called managed ledger, and it chained a bunch of the ledgers together as infinity streams. And Pulsar implemented a whole distribution system concept, like how to load balance the ownership across brokers and how to do geo-replications at the storage there. And at the end of the day, the protocol itself is a very thin layer built on top of this distributed log storage. And people can just play with Pulsar using the producer interface and consumer interface. And so we kind of think, okay, the fundamental or the core of Pulsar itself is not the protocol itself. The core itself is a dispute infinity stream storage that is powered by a great architecture. And then we kind of think, let's wait for a minute. Can we just abstract this interface into a generic protocol handler framework? And this would provide the foundation for other developers to develop different messaging protocols for Pulsar, and that would help the whole Pulsar project growing and also reduce the barrier for people to adopt Pulsar. And that leads into the creation of protocol handler framework. And it's a framework that plug into Pulsar cluster, then it interact with existing Pulsar libraries or distributed log storage. You are exposing, you only need to write the protocol handler to take the incoming wireframes and translate into operations that would happen to the dispute stream storage, and then send the response back as the protocol wireframe to the client. And that is the protocol handler framework, and you can use for implementing different type of protocols. And we introduced that as PIP41. It's an interface that everyone can use for developing a protocol for Pulsar. And the protocol handler itself is just a non-package. So you can just build your protocol handler and package the handler as a non-package and drop it into the protocols directory, and Pulsar broker is able to realize that is a protocol handler and load the handler. And it's very similar as how we load other plugins like Pulsar functions, connectors, and offloaders. And to use protocol handler, you need to making sure your Pulsar cluster is upgraded to at least 2.5. And you need to setting the following configurations that there are basically two settings. One setting is called protocol handler directory. That is the directory that Pulsar broker looking for all the non-packages for the protocol handlers. And the other property is called messaging protocols. You can set to the value that you want to the broker to load those handlers. And after you configure these two settings, and you just restart your broker, and you enjoy a new broker that is able to speak both Pulsar protocol and other protocols that support by the protocol handlers that is loaded by the broker. And this is the way we implement Kafka-on-Pulsar, which we call KoP protocol handler. And I think I'll hand it over back to Pierre. He would deep dive into the implementation.
Thank you, CJ. So I will be speaking about the KoP implementation. So first thing to understand is that Kafka and Pulsar are kind of built on the same data structure, which is called a distributed log. And because they're built on the same data structure, there are a lot of similarities between those two words. And okay, and there is things like topic lookups, which are kind of words valid in both worlds. There's this idea that you have a topic which is holding partitions. The idea of message is also there, offsets. And you have these keywords of actions which are produce and consume. And as I've explained before, consumption is kind of hard. So there is this consumption state, which is really important. So what did we did? How is it working underneath? So we are using the topics from Pulsar. To simulate offsets and message ID, we are using internal information from Bookkeeper, which are called the ledger ID and the entry ID. When we are receiving a message from Kafka, we are simply converting the fields, the structure fields. So we are converting the key, the value, the timestamp, and the headers to Pulsar messages. To do a topic lookup, we are simply using the regular way, Pulsar way. So we are asking the Pulsar admin topic lookup information. That will answer us which broker is the owner of this topic. And for the produce action, what we are doing is that we are receiving the message, convert it, and then we are using internal methods that are available within the broker, which are pulsartopic.publish message. And on the consuming part, we are doing exactly the same. So we are converting the request, and then we are using a cursor, a non-durable cursor, and we are reading entries on it. And one last thing that we did is that we kept the group information in a topic called __ offsets. So this is like an important topic. Every Kafka user know that one. It's an internal one, and it's mostly using for monitoring stuff. So we really want it to be plugin replacement for Kafka. So we backport this functionality as the __ offset topic. So so this is like the checklist of what Pulsar provides. So I will go just briefly on it. So Pulsar provides multi-tenancy, security, geo-replication, tiered storage, schema, integration with big data ecosystem. So because we are running on top of Apache Pulsar, we have geo-replication and tiered storage enabled on Kafka-on-Pulsar. And then we decided to work on multi-tenancy and security. So yeah, let's dive in a bit on those. As you know, Pulsar has a great support for multi-tenancy, and we were always asking how to reflect this multi-tenancy in KoP. So we decided to do something really simple, and we are using Sasso-Plane to inject information. So you are using the username of Jazz, Kafka Jazz, and this is the tenant namespace that you are providing, which allow us to list the topic that you have, and then the password that you are passing to the authorization is your classical Pulsar token authentication parameters. And because Sasso-Plane is in plain, we added TLS support. So you can add TLS support over Sasso-Plane. So this is how it looks. You are defining you are giving a tenant your token. There is this JAS template, and you are just passing this into the properties file that you are using with your Java client. And we think a lot about all the users that are not using Java. So we implemented some integration tests, which are using test containers. So what we are doing is that we are starting containers that are producing and consuming messages from other languages and different kind of Kafka libraries. And we are checking that everything is working well. So when you are running a test on KoP, you are starting this integration test, and you are testing clients such as the Sarama in Golang, the official Kafka Confluent, and we have also some tests in Rust and Node.js. And most of the clients that are using Liberty Kafka should be working. That was like a goal on our side. CJ, do you want to take this one?
Yes. So thank you, Pierre, and so there's still quite. So KoP is our first effort on trying to make Pulsar as a very generic event stream storage that can be used, can be leveraged for building out for different messaging protocols. And we have already have a bunch of users that are using Pulsar in production, and they're migrating some of the existing Kafka workload to KoP and to enjoy the whole like the functionality providing by Pulsar ecosystem. And we will have some of the blog posts coming up in probably next couple of weeks to talk about KoP adoption. But at the same time, I would like to share a bit more because we are not done yet to complete some of the items that we want to leverage for Pulsar. The first thing is for everyone who used Kafka before, you might know it's very difficult for running Kafka in Kubernetes environment because you have to expose the internal address for the broker to the public world. And Pulsar is in favor in being used in Kubernetes environment is because it has a proxy there. And the idea here is we also are looking into a proxy there, is able to proxy those Kafka wireframes to KoP. And the next big item is, as Mathieu mentioned in the keynote, is the Pulsar is evolved, the storage of Pulsar is evolved into a structured event storage. Then schema is super important for a lot of use cases, and we want to make sure schema is able to use by both Pulsar application and as well as Kafka application. So the schema integration here involve integrating with existing built-in Pulsar schema, as well as make it work with conference schema registry, so people can use the schema seamlessly in both ecosystem. And for sure, Kafka transaction support is on the to-do list. And we were waiting for the Pulsar transaction to complete so we can figure out a better way to integrate these two transaction systems together. And besides that, I think in order right now, the KoP support protocols from 2.0 to 2.3, and I think there's a typo here. And we want to support Kafka 1.x versions, and as well as a newer version, I think 2.4. And that there's some ongoing efforts on making this happen. So try to close the kind of the session here is for sure you can the KoP effort is all public. You can it's open source in Apache license. So you can download and try it and give us feedback. You can find us in Slack channel, both Pierre and me. To close the kind of the conversation, we want to push the limit of Pulsar into kind of next level to demonstrate or verify that Pulsar, the whole foundation of Pulsar itself, is a truly stream storage that is able to provide all the infrastructures for developers to developing different type of messaging protocols. Kafka is for sure is a very simple one. Is Kafka has and Pulsar share a lot of commonality, especially they both are building on the same concept, dispute log. But in order to support some more traditional messaging protocols such as AMQP, we want to show that the foundation of Pulsar itself is great enough that you are able to support existing messaging protocols and also reduce the barrier for other messaging protocols, other messaging applications to use Pulsar. So that leads into the creation of AMQP-On-Pulsar. It's a corporate work between China Mobile and StreamNative. China Mobile use AMQP a lot, and they have the needs for scaling up their AMQP clusters and to more dispute architecture. And so the effort was kind of initiated by both parties, and we are happy to announce that work is open source earlier this week, and it's open source under Apache license v2. Currently, it only supports the AMQP 091 protocol, and AMQP 1.0 is not totally different, but quite a lot of difference between these protocols. And we hope we would support AMQP 1.0 at some point. And to give you a kind of brief idea, I think I'm running out of time, but to quick close this is the for the AOP basic is in the AMQP protocol, there's many different concepts like exchange, master router, and queue. And so we kind of map the exchange into a topic, and using the replicator mechanism within Pulsar, and to dispatch the message via a master router into different index topic. And that index topic is used as AMQP queue. So this is kind of the whole architecture. But as you can see here, all the building block here from Pulsar is the topic itself is a dispute log, and the index topic is also a dispute log. And the replicate mechanism in place is actually the replicator that Pulsar used for geo-replication. So all the foundation is provided by Pulsar itself, and AOP is just combine this foundation to provide the AMQP protocol. And another, since in AMQP protocol is your AMQP application is interact with vhost. So vhost is a unit for serving bunch of the exchanges and queues. And we map the vhost into a namespace bundle. A namespace bundle in Pulsar is a bunch of topics that are assigned to a given broker. And this fit very well into Pulsar's architecture. So this is kind of the way how we build AOP. And similarly, as one of the challenges we mentioned in KoP is in AOP, you also, because Pulsar is a distributed system, you want to give a single URL to your user, so the user can use that to talk to the AMQP queues and exchanges. But you don't want like give a different type of the broker address to your AMQP client. So we introduced a kind of proxy service, but the proxy service is actually built in within the ALP plugin. So there's no additional service, but it's just like the protocol handler would handle all these proxy, would proxy all the traffic to the target brokers. So this ensures that you can just hand over a single service URL to your AMQP client, and that they can connect to ALP, and ALP will just figure out what is the right broker to send the request to, and then collect the response back. And it's also open source, and feel free to download it and try it out today. And I think it's time for take some questions.
Yes, thank you, CJ. Let's open the questions. So, okay, we have two questions. Does KoP works with Pulsar 2.5.2? Yes. Yes, you just need to download, to follow the instructions on the slide that CJ showed. It's basically download the NAR file, put it into the right folder, and specify the in the configuration where to load protocols, and you are good to go.
And hey, Pierre, we also had a question come through the chat function.
Yeah.
Does OVHcloud have a blog for V1 on KoP?
Yeah, I would have called it V0 because it was not working really great. But yeah, the implementation was really nice and fun to do. But sadly, no, there was no blog post for this. We did a blog post on KoP, but not on the proxy part, sadly. Sorry. Do you want to take that one, CJ? Is LibRD Kafka supported?
Actually, let me see.
You lost something. Okay, we just answer it. So LibRD Kafka is the main library used to speak Kafka, and almost all versions of LibRD Kafka should be fine, except I think the last one, because we have some breaking changes on the protocol on Apache Kafka 2.4, and there are a lot of breaking change, and LibRD Kafka is already synced on with these changes. So all versions should work except the last one, the newest one. But we have issues, and we are working on this side.
So I can take the next one. Does KoP support Kafka transactional operations? Not yet. So as we mentioned, that Pulsar transaction itself is still under developing, and we have about like 70% of the work are done, and it's expected to release in the 2.7 release. And after that, we would integrate KoP with Pulsar transactions to support the Kafka transactional operations. And the last question is, are there plans to support any other formats? I know MQTT was mentioned. So MQTT was the next one we are going to release in probably a couple of weeks. And MQTT is a bit simpler than the than other protocols, and so we would so it's a bit different from like a KoP or ALP. ALP is probably the most difficult one, and MQTT is it's a much simpler one to implement. And there's already some people testing out MQTT on Pulsar, and so hopefully we would have a blog post about MQTT on Pulsar release version. Okay, so are there plans for gRPC protocol handler? Yes, there's an ongoing effort on. I think it's contributed from Chris, and the plan is also adding a gRPC protocol handler for people who want to develop a client for Pulsar. They can use gRPC protocol. And since this question was raised about gRPC, one of the idea here is actually for trying some of the other I would say serialization and deserialization framework. For people who use Pulsar already, they probably know Pulsar is using customized protobuf version. I think it's 2.6. In order to keep the compatibility, it's really hard for us to bump that version to probuf 3, because we did a lot of optimization around probuf 2.6 in order to reduce the object collection, reduce the number of the objects generated by Pulsar code. And that customization is maintained by the Pulsar PMC, so it's lagging behind the protobuf version. And so if we want to bump the protobuf version to a newer version, we have to do this set of customization again. So it might be a good chance for us to evaluate a different serialization framework to see how we can achieve kind of better performance, and while making sure the code is able to maintain and sustain when the serialization framework evolves. Last question, Pierre, do you want to take it? I think that is in your to-do list for a while.
Yeah, so last question, is KoP available from Pulsar proxy? So sadly, not yet, but we are working on it. So this will be, I think, done through a Kafka proxy directly.
Cool.
Awesome. Oh, did you have something else to say, CJ?
No, I just see there's a question. Is the Kafka support? I think Pierre already answered that. Sorry.
Oh yeah. Mm-hmm. Awesome. Well, that is perfectly brings us up right to time. Thank you so much, everyone, for tuning in. Thank you, CJ and Pierre, for the amazing session.